Mm. What do you teach in your program?
A spread of classes, 145, 191. So that's Gen Ed, math, and calculus, and then what kind of varies by semester, but typically like one upper level course each semester, depending on the semester.
Okay.
Mm-hmm. I have a couple math ed majors in my class right now, so that's a lot of fun.
Okay. So we have video. It doesn't look good there, but I think what they see
very good.
will look fine. So
you're famous.
I already am.
Wow. All the more famous now.
Thank you. I wanted to tell you I appreciated your presentation at the President's Council. Good job.
Oh, thank you.
Very nicely done, and your students were quite impressive.
Oh, yeah, they're top notch.
Yes, they are.
Maybe you should join so that you can see if you can share screen.
Yeah. Let me go back and find it. Right.
Okay. Hello and welcome. Can you hear us? She's not muted, so that makes me nervous.
I'll try unmuting mine.
Yeah, let's see. You know what? Let me turn my mic off.
Yes, I can.
Oh, there we go.
Okay, so you can hear us then?
Yes.
Perfect. All right, and we can hear here. You're welcome. Well, this is Anthony Bosman. I'll let him introduce himself, and I am Lori Imasiku. I am a faculty member here in the Department of Teaching, Learning, and Curriculum at Andrews University, and we are here to present our math Zoom session. These are monthly sessions that go over topics that our teachers in the field have suggested that they would like just kind of some tips and tricks to take into their classrooms to help them strengthen their skills in these areas. So tonight we're talking about math. And if you want to introduce yourself a little bit, well, I guess I should. I have a background in teaching. I have taught middle school math for 10 years previous to coming here, and then I've been a faculty here in the Department of Teaching, Learning, and Curriculum for 5 years now. So.
Excellent. Yes, I started in the mathematics department here at Andrews University. My background is in pure mathematics in the university setting, although I'm also really interested in mathematics education as well. And I'm curious, can you tell us a little bit about yourself and maybe in what capacity you serve, so a little bit of context?
My name is Charmaine Mitchell. I am a kindergarten teacher, have been for the past 3 to 4 years at our local Seventh-day Adventist school. I've worked in the public school system for about 7 years at least. I'm also with kindergarten. I'm not sure what else you might need to know.
That's great.
Yeah.
Where are you located?
I am in Winnipeg, Manitoba.
Oh, very nice. And we have another participant here. Was it John? Welcome, John. John, are you able to hear us? There we go. Perfect. If you don't mind introducing yourself and telling us where you are and what you teach.
Not sure I've got a microphone working. Can you hear me?
Yes, we can.
Awesome. I'm John Musselman. I'm an Andrews graduate from 2013. I'm at Spencerville Adventist Academy, and I teach high school math, geometry, and pre-calculus this year.
Fantastic. So we have pre-calculus and kindergarten, so that'll be a fun mix for today. All right, we're going to jump right into our presentations then. We have, we'll both be presenting a little bit tonight, and we'll leave plenty of time for you to ask questions, and I think feel free to, ask questions as we go as well. So we'll send it over to you. So let me go ahead and just stop my screen.
Awesome. So the big idea I want to talk with you about today is active learning in mathematics. And so let me begin with a demonstration. I think, Charmaine, because of your experience with working with kindergarten students, you'll be able to really connect with this. Now, is this, okay. One second, we're just pulling
They see it.
Great, we got the screen up?
Yeah.
Okay, so I want to show you a very brief clip from a YouTube video from how to juggle. So if you don't know how to juggle, here's a video that can teach you how to juggle, and we can do it in 1 minute or less. So here we go. Let me speed it up so that we can go through the video in less than a minute. And so here we go, and we're getting some explanation how to juggle, and it gives you some background. This is where you're going to need to juggle, and it goes through the steps. So step 1 to juggle. Step 2, and you just breaks it down step by step. You start practicing throwing the ball back and forth. Gives you some helpful tips along the way. Step 3 is now you start introducing a second ball, and you start going between the balls. And finally, another pro tip. Now you introduce the third ball. You start doing simple rounds. And the last step is then going to be to just repeat this process, and now you're a pro juggler. So there we have it. In 6 simple steps, we've mastered how to juggle. The reason I like showing this video is because I think a lot of times in mathematics, what we do is we have some process we want to teach our students. And so we stand in front and we break it down into 4 or 5 or 6 steps. So maybe it's something like in pre-calculus, you're trying to teach them how to, I don't know, do something, trig identities or whatever it may be. And so you break it down to nice little steps for them, and then you give them some tips along the way. But the point I want to make is, after watching this video, which did a really nice job of breaking it down to steps and giving you some tips along the way, if you had merely watched this video, would you feel like you're now competent at juggling? And probably you'd say no. Simply watching someone stand out front and list some steps isn't enough to make you competent at juggling. So, Lori, what do you think you need to do in addition to watching this video?
I think I would need to get some balls and actually participate.
Good. You actually need to practice it yourself.
Yes.
And it would be best if you can practice it in an environment where you're getting some feedback and there's someone who can help you along the way. And so when we think about active learning, we're thinking of this question of who's doing the juggling in the classroom. So here's a picture of a classroom from 100 years ago. There are some things that are quite different in classrooms today. It's segregated by gender. You have the students are dressed very smartly, very, very well. Maybe a few of these things are somewhat different than classrooms today. Less technology in the classroom, but still, in some ways, very similar. Someone is standing up front, giving a lecture. The students are watching, taking notes, perhaps. And so the question I have is, who is doing the juggling in this classroom? And it's pretty clear from this picture, the person at the front of the room who's doing all the juggling, showing the students how do you juggle. And the big idea behind active learning is we're simply trying to put the balls in the students' hands, letting the students do the juggling themselves so they can really get some experience with it. They can mess up, they can make mistakes, and we can give them some feedback. And so I'm going to go through a couple examples of active learning and how I've been trying to integrate it into my classes. One, overall, this quote's a nice summary of active learning. So it's how telling is not teaching, told is not taught. So we're doing more than just tell them what the answer is or how to do it.
Yeah, and my family did.
So just to make the case for active learning, here's a couple studies I'll go through very briefly that just show the effectiveness of it. So here is testing students and how well they understand some basic concepts when they leave a physics course. So the freshman year in college, they take some physics course, and in that physics course, they might learn about ideas like force, acceleration, and velocity. The black bars show how well the students knew these before the class. And so, they didn't understand force very well at all. Some of them understood acceleration a little bit, moderate amount of understanding of velocity. And then you see what after the class, they learned something. So that's good. There was some improvement. So now instead of just 10% of students understanding force, 20% of students understood force. So there you have it, some improvement. So the class did something, but didn't do that much of an improvement, right? Like we had all these students sit through the class and still the majority of them did not understand the majority of concepts. And so now you have these new methods, these active learning methods implemented, and this study found that to understand the basic concepts, active learning was able to bring almost everyone to proficiency in understanding these concepts. And so this is one of many studies that suggest the effectiveness of active learning. Here's a similar study that is just looking at how likely students are to fail and what happens when you introduce active learning techniques. There's a lot going on here, but if you focus your attention on the graph to the right, you can see a move from the orange to the blue, and that as you move from the orange, which is the pure lecture, to the blue lecture that includes active learning strategies, the average percentage, the mean percentage of students that fail drops significantly. And so overall, there was a significant movement to the left. Less students are failing in classrooms where active learning strategies are employed. And particularly, students who are typically underrepresented are found to do particularly well in settings where active learning is employed. All students do well, but it especially benefits those who have historically been perhaps disadvantaged. So one last summary of some of the benefits of active learning. In addition to helping students learn the content better, it also helps them develop their self-esteem, have a positive attitude, develop a greater sense of social support. A lot of the stuff is interactive, so they're working with students among them. They end up liking students more. And so there's a lot of other kinds of positive correlations that go along with introducing active learning, in addition to merely improving the conceptual understanding. And so I believe the literature makes a really strong case for implementing as much as possible active learning techniques. And so let me just highlight a couple of them very briefly that I've been relying on. When I think of active learning techniques, something I try and do is rely on this literature about students' attention spans. And there's a lot of research on attention spans that show that students' attention span only goes up to about 6 to 9 minutes. After that, you really start losing their attention. So here's some data looking at how long students watch videos for, the other measures we can use to see that once you start doing an activity for longer than 6 to 9 minutes, you start to lose their attention. And so my general rule is in a lecture, I try to chunk content into 8 to 10 minute intervals. So maybe I'm at the board for 8 to 10 minutes and then I do an activity for 8 to 10 minutes. And then we're doing something else for 8 to 10 minutes. And you chunk the lecture into these 3 or 4 or 5 parts, depending on the length of the lecture. So here's a couple example of active learning techniques. One is just having a group discussion. There are other ones. You can have brainstorming sessions, invite students to ask questions. You can have them work in small groups. A jigsaw discussion is a really neat way where you can have students, like groups of 3 triads, discuss some topics. And they have like A, B, and C in each group. And then all the A's go over and all the B's go over and all the C's, and you kind of rearrange them. And so what they learned in the individual group, they can then explain to the new group that they move to. There's think, pair, share. You can poll them and ask different survey questions. You can have them vote, and instead of just raising a hand, yes or no, move to one side of the classroom or the other. All kinds of different ways that you can introduce some active components into your classrooms. In a few minutes, I'd like to ask you, what are some strategies you're currently doing? I'm sure in the constantly teaching kindergarten, you're constantly doing active techniques, which is fantastic. But I hope that one of the takeaways from this is those very techniques that we learned to do in teaching elementary school and kindergarten students, we need to continue to do with our high school and even into college students. So here are some examples of what active learning may look like. So you don't need to worry about the exact content of the problem, but rather how you might get students to think about it. So this first one on the left, this might be a warm-up question at the beginning of a class to review content from a previous class. But I really like multiple choice problems because if you have a multiple choice warm-up, you can have students vote on multiple choice. And so I don't know if you do any voting in your class. A lot of times there's like high-end expensive clickers you can have your students buy, but there's some other technology as well. One kind of technology you can use to have students vote is something called, well, it's a piece of paper. It's not very high-tech at all. You simply print out a piece of paper, and then when students vote, they fold it into their option, and they raise it up, and that's their vote. And it seems like it's very low-end. It's not particularly high-tech, but I really like this one. You have to let students, if they don't know what they want to do, they can just hold up the card. They have all the options. You can quickly skim the room. You can see, okay, it's mostly green, so most of them got it right, or maybe you see a rainbow of colors, and so you know they didn't. But it's not expensive. You don't have to worry about technology. It's a very simple way to engage students and get instant feedback on how to understand the concepts. A more high-tech alternative is something called Plickers. So if you haven't seen Plickers, Plickers are kind of the best of both worlds because it allows you to record students' responses, but students don't have to use technology. So they're not being distracted on Snapchat or whatever it may be if they're using their phones, or they don't have to remember to bring an expensive clicker to class. They just hold up a simple card, one assigned to each student, and based on the orientation, if they hold it upright or rotated, that will record their vote as A, B, C, or D. And then you just scan the room with your smartphone, and that allows you to record all the students' responses. So Plickers are really neat technology. This is how it looks like in practice. Each student is holding up their card. You can download these cards for free from the internet, and you can just scan it, download the free app, and you can instantly get feedback. It works well with 20 students, 25 students even, 30 begins to push it. Once you go over 30 to 40 or so, the technology is a little bit more shaky. Sometimes you miss votes or something. But especially works well if you have a class of 20 or 25. And one other kind of interactive thing I like to have students do, and maybe this will be the last one I show you, is wiki sticks. So let me move on to, I have a picture of wiki sticks. They're right here. Wiki sticks are one of my favorite things. They're wax-covered sticks. You can buy thousands of them for not very much money on Amazon. They come in all different colors, orange and green and blue. And what you do is you just peel them off and you give them to your students, and a wiki stick becomes their new graphing calculator. They don't need to have a graphing calculator. Instead, they can graph with a wiki stick. And so you print out some graphing sheet for them, and then on the sheet, they can maybe give them some directions. Graph this graph, or graph a graph that has these properties. Graph a function that's increasing, or graph some line of some equation, or whatever it may be. And then what they can do is play around, and they can just stick the wiki stick on the paper, and then it sticks. So they hold it up, and it sticks there. And the nice thing about this is sometimes students are afraid of writing something and making a mistake when doing a graph. And this allows them to make the mistakes very easily because they don't have to worry about erasing. They can just pick up the wiki stick. They can change it if the answer is wrong. Maybe the graph in some lines, so they can easily move it to find the y-intercept. It's really nice for thinking about transformations of graphs, how graphs are transformed as you add various numbers to it, or as you multiply by some constant. And so I really like using wiki sticks as a way to get students to interact with the graph. And it's just a fun way for students to interact with the math and make it a little bit more hands-on. So that's here's one of the several ways I've been trying to use, make my math classroom more interactive. There are other ways I could talk about if we had more time. For instance, name tags. You can pass out name tags where you have like a problem on one and a solution on the other, and students have to find the student with the same name as them, the student whose solution corresponds with their problem. And maybe one says like 2x equals 10, and another one says x equals 5, and they have to find each other in the sea of students. So these can be fun ways to engage students and just overcome some of the anxiety or frustration with mathematics and make it a little bit more engaging. But let me hand it over to Lori now, and she can go through some other techniques and strategies, and then we'd love to open it up for discussion with you guys.
Excellent. If you want to stop sharing your screen, and then I will share mine. So I wanted to bring to you, and maybe you know some of them, but I'm hoping some of these are new to you, so you'll have new things to try even tomorrow. But in your classroom, I wanted to talk about integrating technology into the classroom and how we can, some interesting math technologies that we can use in the classroom. And so the first one I'm going to talk about, I assume that everybody knows, but I know it's not good to assume, and that is Khan Academy. And so I cannot see them anymore. Where did they go? All right. Well, you're there. I just can't see you. Can you see them?
Yes.
Okay, good. Okay, we'll just do it that way. Just by a show of hands, maybe. And you can actually raise your hand with a little button if your camera's not on. But are you familiar with Khan Academy? Have you used it before? You have? Okay, fantastic. So I really like this program. You can see as I pulled it up, we're doing SAT prep in one of my classes, and so they have that available. But they have everything from kindergarten to high school and even beyond, I would say, for math. And I really like that kids have the opportunities to work at their own pace. They have some really great programs in addition to grade level. They have the new Engage New York program here on Khan Academy, which I think is really, really helpful. And I do like that this program is both online and in app form, so they can actually engage in it on their app as well. The tutorial videos, I think, are well put together, but also just the progress that you can monitor. So just in case, just to make sure that you are using the full potential of this website, do make sure if you're using Khan Academy that you look at the teacher dashboard and that you're having your students connect to you, so that you're creating classrooms within Khan Academy, and that way you can monitor what they're doing on Khan Academy. You can actually assign them assignments. And there's really great resources on the website to walk you through each of those things. But you can actually see what your students are doing and their progress, how much activity. This is going to be a bad example because they haven't, this is an old class, but so you can see how much they're doing, what kind of things they're studying, what they need help with. And so this is a great tool for you to use in your class. So you see, I can see that this person was studying for 145 minutes on this day and did these topics. So Khan Academy is just a really great resource for you. And I like the interface on the phone even. It still works really, really nice on the phone. I also I teach an integrating technology course, and one of my students brought this program to me, which is called QThink. And I want to show you the little video. It's a little under 2 minutes that kind of introduces you to QThink. Has anyone used QThink before? Yeah, this is something that's very new to me. So let's watch this short video and see what you think. Their tagline is oh, it's already done. Let's watch it again. Make math social. So again, that whole act of learning and working together and collaborating. Okay, so we get the idea. What this really does is I think a lot of our standardized testing is actually going to more of the problem-solving method rather than just going straight multiple choice. Here's a little problem and let's try to come up with one of the answers, but really moving into that problem-solving model and that critical thinking. And so programs like this, and I don't support QThink only, but I think it's a great model that's out there right now. Helps you. I have it pulled up here. Helps you. Am I not logged in? There we go. Helps you create problems and then to. Oh, I'm sorry. What is this? I hate when they pop up bubbles and then you can't get rid of the bubbles. There we go. Helps you create problems and helps students walk through them step by step. And so I think that's a really great skill. But what I think is most interesting is the idea that students can interact with each other. And so they can be on each other's accounts and make comments, make suggestions, and so forth. And so they're interacting together. Let's see if we can log back in. So here's an example. These are just some scenarios that are already up there so they can write information on what they notice. They have a nice little whiteboard where they can solve with a lot of different graphic organizers and different sort of tools that they can use. But then they can also write notes on there. They can get some review tips. Did I check my work? They can even record their own voice, which I think is really neat on this. And so they can record their solutions in presentation format. You see down here we have so they could record. So just a really great opportunity and tool for students to work on those critical thinking skills, but also have an opportunity to work together and to give each other feedback and build off of each other. So that was QThink. And then let's see. I have time for one more. I do want to show you, and I don't know why it's there we go. So I do want to remind everyone, since I think we're all NAD teachers. Oh, are you not seeing? what I'm seeing?
I think you're sharing the.
Yeah, okay, well, we'll just share again. So, there we go. Since we are all NAD teachers, just to remind you of the technology standards that are out by, set out by the NAD. And so the first set is the K2 standards and then the 3.5 standards. And these are not math, so these are technologies, but using internet resources, programs, and applications to support personal and academic development. And so being able to integrate these kind of technologies into your math classroom can be very beneficial and help you meet those standards that you need to be meeting. And I know that the technology standards are not always on the forefront of our minds. I know we're very clear usually on what our math and language arts and standards are, but we do have, the NAD does have technology standards that we are expected to be meeting in our classrooms. So the one other thing that I really wanted, well, I think two other things, but I'm having trouble getting to it because, all right, let's, math manipulatives. How many of you use manipulatives in your classroom? Does anybody? Yeah, I'm seeing some nodding of heads. And so math manipulatives are really great active tools, and I encourage them in the classroom, but sometimes we can't afford full sets of everything and all the different manipulatives. And so, and we're gonna send this PowerPoint out with all of these links. But this is created by Utah State, and it is pretty much any math manipulative in our traditional math manipulatives that you can think of are all here in an interactive online format. So you don't, and it's all free, and so you don't have to go out and buy counting chips. You don't have to, you know, fraction bars, fraction pieces, all of these things are here and available for you to use. I think the hands-on would be my first choice, but sometimes we can't always get those. And so this is another way for us to have all these different manipulatives. These are just grades 3 through 5, but they have them for all the way up through 9 through 12, and depending on which topic you're interested in and which strand. So they have lots of different ones that you can select from to help them work with those manipulatives. This is another great thing, a tool for them to have at home. So as they're working through problems, they have these manipulatives at home. Even if you have them physically in the classroom, they can have stuff at home for themselves. And then the last thing I wanted to introduce you to would be, and this is again, I think having explanations of different concepts on your walls is really nice. But again, you know, these beautiful posters, and let me just quickly, you know, these beautiful infographic posters that we can as teachers spend a lot of money on, you know, oh, I want a poster on fractions, and I want a poster on you know, on different kindergarten, maybe different shapes and so forth. These can be really expensive, and so if you're not familiar, I did want to introduce you to a free program called Canva. Have you used Canva before?
No, I haven't.
You can create free posters that you can download and then print out and put on your walls. It's very user-friendly. I have no background in graphic design, but it's very user-friendly, and there's plenty of free options for you. I quickly, in about 2 minutes, started of it. I mean, this needs some work, but you know, if I'm teaching about shapes, just quickly putting the shapes, and you would put the titles under there, you know, just, well, that's a little small for you to see right now, but you know, just quickly adding the names of the shapes or whatever you're working on, and then you can print them out in different sort of sizes, or just even just our regular standard, you know, 8.5 by 11 paper, and even hand them out to students. But a great way for you to get these math infographics, which I think are very valuable to students, but you can create them on your own. And so a lot of times, you know, as a class, you come up with different sort of tips and tricks of how you're going to solve, or you may have your own wording in the step-by-step directions of how to solve different complex problems. And so you can create that in your wording and quickly create graphics to share in your classroom. So those were the kind of practical, bring into your classroom tomorrow, free things that you can do. I think we always love free things. And my final one would be, obviously, sorry, there are tons of YouTube videos out there for math, and lots of different, can you still see me? Yeah, okay, perfect. But I did want to introduce you to Math Antics. This guy is well received by many of the students that I've shared him with, and he has a variety of different videos that are available for you. I think they're a little long, and Anthony kind of shared how our attention span drops off. So that would be a critique I would have of this, is you may want to just show piece by piece. He usually talks about several topics within a video, and so you may want to do like a piece of the video and then stop, do some active learning, and then maybe share. But he has them really practical. He has, it's humorous, but it's from every video I've seen so far, clean humor, something that we would feel appropriate to share in our schools. And he has a lot of different videos on different topics from very early numeracy all the way up to more complex math. So this would just be another resource for you. Khan Academy has their own there as well. But I do like that he has a little bit more, he's a little more animated, he has a little bit of humor, but it's still clean and appropriate for our students. I think, I haven't watched every single video, but I always encourage you to preview your videos, but so far it seems to be quite appropriate. So we're actually going to stop talking and allow you the opportunity to ask questions.
If I can share one last resource.
Yeah, sure.
As you were sharing, something came to mind, especially for elementary school teachers. And maybe of some value at high school as well, but especially elementary school. There's a great community called UCubed. And so on UCubed, you can go here and find all kinds of resources for interactive mathematics lessons. It's based out of Stanford University with Jo Roller. She's the researcher, professor of mathematics education behind it. But she has built up a great community here. And in addition to the UCubed page, there's also a very active Facebook community. And so if you're on Facebook, you can join the UCubed Facebook page. And it's a really responsive community where people often ask questions and they get tons of suggestions and recommendations from other educators. And so if you're just thinking of, oh, I'm trying to find a creative way to teach this lesson or whatever it may be, it's a great place where you can go, you can ask your question and expect to get lots of great quality feedback. So again, that's called UCubed, and especially elementary school teachers, although perhaps also academy and secondary school teachers, this is a really valuable resource.
Great, thank you for sharing. I just joined. So,
Yes.
oh, well, no, I have to answer some questions. I'll join in a little bit. Okay, great. So if you have any questions for us or anything you would like us to share with you, now the floor is open. So.
All right. Well, regarding Khan Academy, I just want to make the comment that I use a program here in Canada called Mathletics. And so it's wonderful for starting at kindergarten that they go in and do various activities, and it's more like practice of the various skills that we're doing. So certainly it relates to all the strands, and they really enjoy, for the most part, because they're using iPads to do this, just doing these activities on their own in a different format, right? On a computer. So I will have to check out Khan Academy in a little more detail and some of that other wonderful resource that you shared with me. Thank you.
Great. Is Mathletics is free, correct?
No, there's a subscription that's required, but that's covered for us to have it in all the classes.
Oh, okay.
Up to grade 5 or 6. I'm not sure how high up we go with it.
Okay, great. No, fantastic. I've heard good things about Mathletics. I haven't tried it personally, but I have heard great things. Yeah, Khan Academy is also another great resource for you. I think it is similar in that, you know, you can map their progress and move them through, and each student can go at their own pace. And I like how it's constantly assessing, and so, you know, finding those gaps and holes and making sure that those are filled in for students. It even does, if you're teaching at the high school level, the SAT feature on Khan Academy is really quite advanced right now. It connects with College Board, and so they can actually import actual test scores, and it will diagnose those and figure out what it is that they're not successful on, and then help them begin to practice those things. So it really is starting to integrate well with, that's just SAT. I think it does it for other programs as well, but that's the one that exams as well. But so I like the diagnostic feature of it, and then it really tailors learning. So great, thank you for sharing about Mathletics. Anyone else? Questions, comments?
Just chime in that the primary online resources that I'm using right now, a lot of the application Desmos for a lot of the just accessibility, and it's a little bit more of a friendly user interface than maybe you get on a regular graphing calculator. I'm still trying to push the graphing calculator for the SAT, the ACT, the purposes of that, but it is nice to have something that's a little bit more interactive for the students. And then I use the at least a handful of the NCTM Illumination kind of web applets. There's a few of those that are really good. I'd love to see that library expand a little bit, so it's always good to get more lists of resources.
I'm glad you mentioned Desmos. That's a fantastic resource. I use it often in my classes as well, and just really helpful to help students visualize what's going on and build that intuition. So yeah, it's a great resource. Thanks for sharing that.
Do you want to explain what it is?
Oh, I'm happy to share. I can quickly share a screen. And if someone wants to see what's going on with Desmos, there's all kinds of, you can type in Desmos and just go to Desmos itself. But in addition, so here's the Desmos page. They have a very nice graphing calculator and other options as well. But then they have these really cool, what I think is really nice is they have these really cool visualizers. And so you can pick almost any topic. I'm thinking of calculus topics I usually use it for, but like in calculus we talk about the derivative of sine, and you want to see its cosine, and so maybe that's a little bit more advanced than what you'll be showing in the academy, but they're similar. Any concept typically has some kind of Desmos visualizer with it, and there's a really nice way where you can interact and you can see it illustrates the concepts in some really nice ways. And so this is infinitely superior to me trying to sketch pictures on the blackboard or whiteboard. I still do it sometimes, but then also having this to play with and really develop that. And very easy to adjust, and you can hide features, and you can bring them out as you want to introduce them in the class. And so it's a very nice user-friendly platform. And so I encourage you, if whoever's not familiar with Desmos, to just go to Desmos, play around. Also, if you want to teach some concept, just try Googling Desmos with that name after it and see what comes up, because there's probably something, trig functions or whatever. And there's probably an example of a Desmos applet that's already made that will help you visualize it in a nice way.
Great resource. Thank you, John. Any other questions? Or it's great that you're also sharing resources, and so we will be capturing. So everything that we've shared here, we'll send out to you a list of resources, and then we can actually add the resources that we have discussed here as well to that list. So, anyone else?
Well, just out of curiosity, will you be doing another session in the future, the near future at all?
Oh, great. Thank you for asking. So, yes. So our next session is actually in December, and where it'll be a science session in December, and then January we have a session on school administration. February is classroom management. We have social studies and history in March, and technology in April. So I think there was a little infographic that they sent out, but you should be receiving emails every month letting you know of what topic they're going to be discussing. Okay. And there are, if you missed, we already have reading and ESL, so if you missed that one, they are on YouTube. We can get the link for you so you can watch them later.
All right, super. Thank you.
Thank you. All right. If there isn't anything else, then we won't keep you, because I know it's almost 8 here. I don't know where all of you are, but I hope you have a great night, and we'll send out that information along with contact information if you have any more questions. So.
And for everyone watching live who might be viewing the video later, I just want to thank you and encourage you for what you do. It's just so foundational and important. So we want to encourage you and thank you, and keep it up. Keep up with the great work you're doing. We know it's sacrificial and tiring, but it's really inspirational as well. And so thank you for what you do.
Thank you. Have a good night.
Night.